Let's create a fake Caustics water shader in Godot. This shader is compatible with the GLES2 renderer, but it should also work with GLES3 or Vulkan. Caustics are the patterns of light we see when light curves through a medium, such as glass or water. Simulating this on a computer can be quite computationally heavy, so we're going to create a shader that fakes this effect. In Godot, I've set up a little test environment we'll apply our shader to. I'll create a new shader material called Caustics and add a new shader to it. Set the shader type to spatial and create the vertex and fragment functions. We'll need both of these for this effect. The first thing we are going to need to generate is some Worley noise. Worley noise is a kind of cellular noise similar to Voronoi noise. Fortunately, someone has already written a Worley noise shader and uploaded it to GodotShaders.com. If you've never been there, GodotShaders.com is a great resource for finding shaders and learning how to create shaders. Let's take the Worley and random function from GodotShaders.com and paste it into our shader. I'll post the link in the description to this video. I'm going to go ahead and apply the Caustics shader to my objects so we can see what's going on. In order to keep my existing materials, I'll add the Caustics material to the next pass property of my existing material. This is going to override everything for now, but we'll fix that later. To create our Caustics, we're going to apply the Worley texture to our material's emission property. We'll call the Worley function with our UV plus the time variable multiplied by some constant. This constant will determine how quickly the Caustics move. For the columns and rows parameters, I'm going to set them to 3, but you can change this to alter the scale of your Caustics. Everything is too bright right now. Rather than using our Worley value directly, we're going to plug this into a color ramp. Create a new uniform sampler 2D called color ramp, and get the R value from the gradient using a vector 2 from the Worley noise. Getting the red channel is arbitrary. Since the gradient is in grayscale, we could use the blue or green channel as well. Now I'm going to manipulate the color to get our Caustics. I'll take a minimum of a value close to 1 and the color. This just prevents us from getting a value that is fully white or 1. I found that when the color is 1, I get some strange artifacts, so this will remove that. Next, I'm going to crunch the color value down. I do this by taking a log of a value close to 1 and dividing it by a log of our color. Finally, I'll scale the color value by multiplying it by 50. Then we can set the value of our alpha to color to get the original materials back. In case this isn't very clear, here's a graph of the log of 0.999 divided by the log of our color. You can see that between the values of 0 and 1, we've crunched things way down. This is going to give us those thin lines of the Caustics. You'll notice that the scale of our Caustics aren't applying evenly to all the objects in our scene. The Caustics are large on our large objects and small on our small objects. We can see this even better if we set the albedo to the color. The reason this is happening is because we are using the UV to index our Worley noise. We can fix this by using our object's vertices rather than the UV. Create a varying vector 3 called world position, and set this to the world matrix multiplied by vertex. Then we'll replace the UV with the X and Z component of our world position. Finally, we can see our Caustics. However, it's a little too small for my taste, so I'll create a scale variable to increase the size. Multiply your world position by this scale. The reason we are using the X and Z component of the world position is our Worley function only works on 2 dimensions. I think this has a nice effect of creating even Caustics on the XZ plane, but distorting the Caustics along the Y-axis. And that's our fake water Caustics shader. If you want your scene to look more like it's underwater, you can add some blue fog to your world environment node. You can then mess with some of the constants we defined to change the scale of the caustics, as well as how quickly they're moving. You can set up shader uniforms if you like to tune the values to what you want. Thank you for watching. If you enjoyed this tutorial, consider liking and subscribing, and leave a comment if you have any questions or suggestions on how we can improve this shader.